The Unfinished Brain by Susan Caldwell. Today we are going to talk about the brain before birth, the newborn's brain, the growing brain, the areas of development, the different hemispheres, language development, and early experiences. Research has found that the placenta actually plays a very huge role in infant brain development in the very early stages of pregnancy. And the experiments that have been done on mice, and that they show that during a key period, the placenta actually becomes a source of the chemical serotonin, which helps determine the wiring of key circuits in the brain. So this is actually what has helped explain different brain disorders such as autism and schizophrenia. But it shows that the placenta does a lot more than simply transport nutrients from the mother to the unborn child. That this placenta isn't just a passive bag of cells hanging around freely between the mom and the fetus. That it's the placenta is playing a huge role in brain development long before the baby decides to make its grand arrival. The newborn brain is 1/4 of the parent's brain when the baby is born. By the time they are 5 years of age, the brain size will be 90% of the parent's brain size. And when the baby is born, the brain weighs about 2/3 to 3/4 pounds. But as the infant's brain develops, and it will develop at an amazing rate, research has shown that physical and emotional experiences are what impact the first 5 years of the child's life, and this is what directly reflects their learning ability and their brain growth for the rest of their life. The brain is the only organ that isn't fully developed when the baby is born, and research has shown that it's no longer genetics that's playing the main role in the infant brain development. It has to do more with the baby's environment as the baby grows, which we'll talk further about later in this presentation. When the baby is born, they're born with 100 billion neurons, and even though research has shown that some of these neurons are developed after birth and well into adulthood, the neurons that the babies are born with are primarily what they need to work with and to develop into children, adolescents, and adults. The fetal development is when the neurons are created and they begin to migrate. As they migrate, they also become different. So they begin to specialize in response to chemical signals. Connections among the neurons are called synapses. And synapse is when what organizes the brain by forming pathways that connect the parts of the brain. And that's what governs everything that we do, from breathing to sleeping to thinking, to feeling anything. And after that, the myelination is what provides clear transmission across the synapse. So myelination is the white fatty tissue that insulates the mature brain cells, and it will start forming a sheath. And young children will process information slowly because their brain cells lack the myelination necessary for the synapse. The first areas that are fully developed in the infant's brain are the brainstem and the midbrain. And if you look at the diagram below, you can see right here where the midbrain is, here in the green, and you can see actually the shape of the brainstem. The lower parts of the nervous system are extremely well developed when the baby is born. However, the higher regions aren't so well developed. The newborn's brain will allow the babies to do many things, such as breathe, eat, sleep, hear, smell, feel sensations, etc. However, each region manages its assigned functions through different processes and chemical messengers. And this would be where your neurotransmitters and your hormones come in. When the infant is born, the hemispheres have already started to specialize. And if you look at this diagram below, you can see the left and the right hemisphere. In the left hemisphere, you'll see that that's what controls our speaking and our reading and our right hand touch, where the right hemisphere is what controls our creativity, our left-hand touch, our music, things of that nature. However, newborns show greater electrical activity in the left hemisphere than they do in the right hemisphere. And this is actually what will make them listen to speech sounds better. And some of the areas of the brain, such as the primary motor areas, develop earlier than the other areas, such as the primary sensory areas. A 3-month-old infant's brain has the potential to distinguish between several different spoken sounds. It was Charles Nelson's discovery when he measured the activities of the infant's brain by attaching 128 electrodes to the baby's scalp that measured the brain's activity. It had been found that even newborns can produce distinctive brain waves that reveal that they can distinguish between different sounds. And the neatest thing about this discovery was that Charles Nelson found that babies can distinguish their mother's voice from another woman's voice when they are asleep. And this is actually a really neat discovery because many people wouldn't think that this would be the case. Research has indicated that babies that grow up in environments that are deprived have depressed brain activity. Below, if you look at the figure A and B, A is the PET scan of a normal child, and B is the PET scan of a child that's grown up in a deprived environment. A, you can see that the blue, the red, the yellows, and the blacks are very bright. But if you look at figure B, you can see that the color is very diminished and very gray. What this is indicating is that negative forms can lead to lifelong developmental delays in babies. Any kind of neglect or stress or trauma results in brains being anywhere from 20 to 30% smaller than the average brain. So it's not so much that genetics is causing children to be developmentally delayed in today's world, but more the experiences that they experience as infants and the environment that they grow up in.